is about linear combination and spanning. Okay, I think linear combination, some of you have seen it in whatever, in matrix or in who have diploma or who have form 6. Okay, so let's see definition of linear combination. Okay, you are given vectors b1 until bn, that is in V, and scalars c1 until cn, that is in R. A vector y is called linear combination of a vectors b1, b2 until bn if it can be expressed in the form of y equal to c1 plus c2 plus dot 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 plus cbn. Okay, so what can we see here? We see that this vector y can be written as addition. Okay, the addition of all the scalars multiplication of the other vectors in V. So we said that if it can be in this form, we said that y is a linear combination of that vectors. Okay, let's see examples. Determine whether or not y is a linear combination of the given vectors. Let's see the first one. Our V now is R squared. Okay, the ordered pairs. R squared is second dimension. And y is 2, 1. And V1 is 1, 1. V2 is 2, 2. Okay, how could we do this? How can we see that y is a linear combination or y is not a linear combination? So we need to find, go back to the definition just now. We need to find whether C and all the C's. Over here we have V1, V2, so we have C1, C2. The C1, C2 exists. So that y can be written as C1 plus C2, C1 V1 plus C2 V2. So we need to find what are the C's. Okay, so here we can say that, can we find the C's such that 2, 1 can be written as C1, 1, 1 plus C2, 2, 2. Okay, now we need to solve it. How to solve it? So coordinate x equal to coordinate x. We need to multiply the C's inside, C2's inside, C1 inside, so that we can equate the equation. So what we have here? Anybody? Anybody?
Doctor, it will become 2, 1 is equals to C1 plus C2, no, 2
Okay,
C2.
this is what you said, Surya.
Yes.
So from here, what can we have? The x coordinate should equal to the x coordinate of the y. The x coordinate of the addition on the right hand side has to equal to the y coordinate of the left hand side. So what can we have? What is this? This is C1, C1 plus
2 C2,
2C2,
2 C2.
2C2. Okay, what else? We have C1 plus 2C2, comma, the y coordinate C1 plus 2C2, right?
Oh, okay.
Okay, then what we have? This should equal to this. And this one should equal to the y coordinates. So what we have?
So we have 1.
C1 plus 2, C2 equal to?
2.
C1 plus C2 equal to 2. Another one?
Plus
C1
2
plus
C2
2 C2
1.
is equals to 1.
That's right. That's right. So we need to solve it. We want to find C, right?
Yes.
So we want to find the two C's. We have two equations, so it's easy to do that.
Use quadratic equation.
You
Okay.
have to use the what? Not quadratic equation. You use what?
Quadratic function.
Simultaneous equation.
Simultaneous equation.
Or,
Yeah.
since we are in linear algebra course, we use the Gauss elimination. Right. But this is just 2 by 2, so it's easy to use whatever you want. So, okay, let's see. 1, 1, 2, 2, 1, 2, 1. Okay, take this out. You have negative R1 plus R2. So you have 1, 2, 2, 0, 0, negative 1. Okay, what can you say here?
Nice.
What can you say? Anybody, what can you say here?
No solution.
No solution, that's right. Why is it no solution?
Because the unknowns are equal to -1. No.
That's right. So 0, 0 equal to negative 1. That's not valid.
Yes.
Right? So, not consistent. C1 and C2 does not exist. Hence, Y is not a linear combination of the vectors. Okay, any question here before you guys do number 2? Any
Doctor,
question? Yeah.
explain like the one in the circle, the SLE is not consistent.
Here what we have? Here we have what? If you solve this, we have what? C1 plus 2C2 equal to 2.
Okay.
Over here, 0C1 plus 0C2 equal to 1. So 0 equal to 1 over here. This is not a valid statement.
Oh, okay.
Okay?
Okay.
It's not defined.
Yes, doctor. Okay.
All right. Okay, good. The number 2. Is Y a linear combination of V1 and V2? Do the same thing. I want to see some answers. Put on WhatsApp group. Let me see my WhatsApp group. Okay, wait. Can I have some? Oh. Nurul Anissa, I give you 2 minutes. Okay, Nurul. Nurul Anissa.
Yes, Doctor, I try.
Where? Oh, tak dengar suara Nurul. Nurul.
Yes, Doctor.
Tak apa, check. Nurul, okay. Masih nampak skrin saya kan?
Nampak, Doctor.
Yeah, Doctor.
Nurul suara tak dengar lah. Something wrong with your mic, I think.
Tapi Doctor, we can hear Nurul's voice.
Oh, why can't I hear Nurul's voice? Saya tak dengar.
Can Nurul speak again for Doctor?
Yes, Doctor. Are you hear me?
Tak dengar lah. Late.
Oh. Oh my God. Okay. Doctor can hear my voice. Okay.
Yang lain cuba cakap. Tarmizi, cuba cakap sikit. Kenapa saya tak dengar? Audio devices, change audio connection. But I hear your voice, Surya.
Yeah, for just now, Tamizi's voice also I cannot hear, Doctor.
Oh, yeah?
Yeah.
Doctor still can hear me.
Don't waste time. Nurul, are you ready, Nurul?
Not yet.
Can you hear Nurul, Doctor?
Tak ada. Tak, I tak dengar.
Dia tadi cakap, Doctor.
Kenapa I tak dengar Nurul cakap? Ya Allah. Tak apa, Nurul chat. Cuba cepat. Is there something wrong with my speaker? No, sebab saya boleh dengar Suria. Okay. Nurul ready, Nurul? Post kat WhatsApp. Gambar post kat WhatsApp. Cepat. Dapat separuh tak apa. Nurul. Tulis sikit. Tengah buat ke apa? Okay. Can you share what you have done? Tak apa, dapat sikit pun tak apa. Ada sesat. Tuliskan Nurul dalam bentuk Y sama dengan C1V1 plus C2V2. You should have this. Next. Apa ni? Okay. C negative C1, negative C2. Okay, Nurul. Good. If you guys look at the, okay. Mana saya punya tu tadi? WhatsApp. Okay. Have a look at Nurul's answer in the WhatsApp group. Saya tak ambil pula. Ya Allah. Okay, so Nurul got all the equation there. Negative C1 equal to negative 3. C2 equal to 2. For C1, negative 2 minus 2 C2 equal to 8. C1 minus 2 C2 equal to negative 1. C1 plus 3 C2 equal to 9. 5 C1 minus 6 C2 equal to 3. Okay. Okay. Cuba tengok ni. So betul? Nurul dah dapat? Okay. Tapi, you see here. Do you need all these things? You already got here. C1 itu, oh, yang ni silap sikit kot. Negative C1 kot. Negative C1 kan? Negative C1 equal to negative 3. Here you got negative C1 plus 0 C2 to negative 3. So silap sikit Nurul sini So C1 equal to 3. C2 equal to 2. So you don't have to add all these things. Okay. If you get also use this equation, use the equation, you will get the same thing. So you don't have to find all that. Boleh? Okay, Nurul? So what we have? So we have negative 3 to 8, negative 9, and negative 1, 9, 3 equal to 3 times V1 plus 2 times V2. So what can we conclude here? What can we conclude here?
Has one solution.
Y is a linear combination of the vectors because we can find the C1 and the C2. Okay. Boleh tak? Any question?
Doctor, for just now, it is like there is no solution. So we should say that Y is not
No. Yeah.
linear combination.
Yes. Y is not a linear combination. I wrote that, right?
Yes.
Oh, tadi yang jawab Anis Bukan Nurul. Nurul Anis lah ya.
Yes, Nurul Anis, doctor.
Okay. Pelik. Pasal apa saya tak dengar suara orang lain? Tak apalah, as long as you can hear my voice, okay?
Yeah.
Alright, so try another example. Is this B a linear combination of vector in S? So the vector in S is negative 1, 2, 3, 0, 1, 5, negative 1, negative 2, 3. Same thing, we need to find C1. How many C's here?
3.
3. That's right. We need to find C1, C2, C3 such that this is true. So, find the 3 equation. Okay, let's do it together. We have what? Negative C1 plus 0 C2 minus C3 equal to negative 1. 2 C1 plus C2 plus negative 2 C3 equal to 7. And we have 3 C1 plus 5 C2 plus 3 C3 equal to 16. So there's no shortcut ways to get all the C's. You need to solve the 3 by 3 equation. So use the Gauss-Jordan elimination. We have what? Negative 1, 0, negative 1. Negative 1. 2, 1, negative 2, 7. 3, 5, 3, 16. Okay. You guys do the elimination. Give me answers. Dia dapat jawapan dah? Dah? Siapa dapat jawapan? You kan sudah elimination dah. Cepat. Awak lambat. Okay. Who gave the answer? Yes. Okay. Buat Anis juga. Alamak. Webback has stopped. Okay, nampak dah balik? Suria? Screen?
Dapat doktor. Dapat, ya.
Okay, cuba kita tengok ni. Okay, negative R. Okay, fine. So, kita dapat 1, 0, 1, 1. Okay, yang lain. So, yang ni you buat negative 2R1 plus R2. Okay. 0, 1, 2, negative 2, negative 2, negative 2, negative 4. Okay. And then negative 3 R1 plus R2. So you have 0, 5, 0, 13. Okay. Kita tengok yang satu tu dah ada 1. Okay. Negative 5 R2 plus R3. 0, negative 5, 0, negative 5, negative 20. Ni betul ke ni? Negative 5, negative 4, 20 plus 0. So it should be 30. Betul tak? So ni dah salah. Okay, Anis. Be careful. Alright, when you did mengapa ni? Internet tak ada ke? Sat saya pakai data saya. Nampak Suria?
Yes, doktor. Dapat. Dapat, doktor.
Okay. Alright. So, tadi Anis juga yang buat. Nampak kesalahan. Kena be careful. So far sama je macam saya buat. Okay. So, kita dapat apa? So, kalau tukarkan ni pun kita nak Gauss-Jordan elimination, kita 1 over 20 R3, so you dapat ni 3 negative 4 and 1, so we have 4 R3 plus R2 R5 plus mana dia? R3 plus R1, R3 plus R1 ke? Negative R3 kan? Supposed to be plus R1. Okay, kita dapat apa? Betul tak? Cuba check. 4, okay, mati 0. 4, negative 12. Negative 12 over 5 plus 5. Negative 4. Okay, negative 12 over 5 plus 25 over 5. So, dapat apa? 13, betul kan? 13 over 5. Okay. And then, negative R3 plus R1. Negative R3 plus R1, so 0. Negative R3, so kita dapat 3 over 5 plus 5 over 5. So we have 8 over 5. Good. So that's the result for the C1, C2, and C3. C1, 8 over 5. Yeah.
Doktor continue dulu. Okay, Doctor, if in these work steps all, if let's say, okay, we take a look at this negative 5 R2 plus R3, okay, after we do, on the third row, we got all 0 is equals to negative 12, like 0, 0, 0, and then negative 12.
Yeah. Negative 5 R2 R3.
Yeah.
Apa you dapat 0?
No, Doctor, I didn't get 0. If let's say, if we got all 0, so it will become no solution lah. So
kalau macam yang macam Anis tadi dapat, kalau dia punya ini, memang yang tu no solution, yang dia dapat 0, 0, 0 equal to 8 kan?
Yeah.
So that one should be no solution lah, tapi Anis dah buat kesilapan.
Right. Okay, Doctor. Yeah.
Tapi kalau you dapat 0, 0, 0, then 0 at the end, then it's fine.
Yeah, okay.
So it's many solution for that.
Okay, Doctor. I got it, Doctor. Thank you.
All right, you're welcome. Okay, so what is the conclusion here? V is a linear combination of the vectors in S. So the V looks like. Okay. Question?
No, Doctor. So far, so good.
All right. Let's see another example. Polynomial now. Is PT equal to t cubed minus 2t squared plus 1 a linear combination of vector S. The vector S consists of 1t squared t cubed. So it's just the same thing. How many C's do you want to find here?
3.
3 kah?
4.
Kita ada ni. So it should be 4.
Yeah.
So we want to find C1, C2, C3, C4 such that this is true. T cubed minus 2t squared plus 1 equal to C1 times 1 plus C2 times t plus C3 times t squared plus C4 times t cubed. So this one is easy, right?
Yes.
Polynomial is equal to another polynomial. So the coefficient of the same variable should be the same. So C1 equal to, C1 is the scalar, equal to the scalar. So we have C1 equal to 1. C2, sini tak ada T, C2 equal to 0. C3, depan T squared. So sama dengan negative 2. C4, depan T cube sama dengan 1. Everybody agrees?
No, sekejap, Doctor. Wait. Okay, wait. C1 is equals to 1. Okay. So C2, why it is equals to 0, Doctor?
Okay, kat sini ada untuk T tak? Variable T tak kita?
No.
T. No. So that means here, if you rewrite this, it becomes T cube minus 2T squared minus 0T plus 1.
Oh. Okay. Okay, Doctor.
Okay.
Yes, yes.
Tadi saya dengar suara siapa dah bunyi dah tadi?
Kan? Aku dengar. Hello? Anyone there?
Hi.
Anyone there? Okay. I think because of my internet actually.
Suara doktor pun macam ke dalam keluar ke dalam kedua.
Oh, ya ke? Okay.
Yeah, now okay, Doctor.
Okay, now the conclusion is PT is a linear combination of vector S. And number 4. Anybody want to try this?
Wait, Doctor, I'm trying here.
Okay. The rest.
Hi, doctor.
Okay, ada yang dapat jawapan? Okey, apa dapat jawapan?
I think I'm stuck at the very first step, doctor.
Why do you start at the very first step? Because this is quite easy. Okay, let's go. Okay. You want to find C1, C2, C3, C4 such that this is true, right? T2
Yes.
to T2 plus 1 equal to C1 negative times negative 1 plus C2 times 1 plus T plus C3 times 1 plus T plus T squared plus C4 times T plus T squared plus T cubed. Where do I get this? All the vectors there.
Yes.
Okay. So now you need to combine lah. Kita dapat apa? Negative C1 plus C2 plus C2T plus C3 plus C3T plus C3T squared plus C4 plus C4T plus C4T squared, right? Plus C4T
Cube.
T cube.
Mm.
Okay, and then what do? Combine. What?
Simplify kan?
Combine the same variable. Huh? Combine the
Yes.
same variable. Okay, now look at the formula, the scala. So we have only one, negative C1. Okay, now in front of T. Apa in front of T? Tak ada. Sorry. Untuk yang pemalas ada apa? Negative C1 plus C2 plus C3 kan? Silap. Okay. So kita ada apa? Untuk yang we have negative C1 plus C2 plus C3. Betul?
Okay.
Yes, doctor.
The one without T is it, doctor?
Yang without T plus C4.
Yes.
Number one.
So we have negative C1 plus C2 plus C3 plus C4.
Okay.
Right.
Uh-huh.
And with the T kita ada
C2. C2T
C2 plus C3
plus
C4.
C4.
plus C4. Ada lagi? Tak ada. Right?
Yes.
Okay. Plus T squared. T squared is done here.
C3.
C3. Okay.
C4.
C4 plus C4. T squared.
T
Habis
squared.
kan?
Yes.
Okay. And then ni dah habis.
C4 saja.
And then one C4 saja plus C4 T cube.
That was T square, doctor, up there. The green, the green one is T square.
T squared. Okay, the green one is T squared. Okay. So now you equate the variables, you equate the coefficients of the same variables on the left and on the right.
So C4 would be 1.
C4 with C4. This one.
Yeah. So C4 will be 1 lah.
Yep, C4 will be 1. Okay. 481 and then C3.
Negative
Boleh dah?
3.
Indah.
Negative 3.
Dah go the So back substitution, you have C4 to 1. C3 equal to negative 2, negative 1, negative 3. C2 equal to that. And C negative C1. C1 equal to negative 1.
Okay.
So that means that all the C's.
Yes.
So that means PT is a linear combination of that.
Oh, okay, doctor.
Okay. Try 5. Try that. Number 5.
So, doctor, is it the same step we need to follow as C1, C2, C3? Kan?
Yes, that's right. Yeah.
Okay. Okay. Okay.
Because the question is about a linear combination.
Right. Okay. Okay.
Same thing here. Look at this far. Did you get that far?
Yes, Doctor.
Okay, so here, you can just use back substitution, right? Or if you want to use the Gaussian elimination, that's fine. Tapi tak perlu, saya rasa. Right. You get here C1 equal to C1 equal to 2. Here you get C3. So C1 equal to 2, C3 equal to negative 2. Over here, you got C2 equal to 1 plus 2 equal to 3.
3.
Betul?
Yes.
What version pun apa. So you got V is a linear combination of that vector X.
Doctor,
Yeah.
for the yang sekejap, yang C2. Wait, I'm confused, Doctor.
What? Confused? Which one?
The okay, wait. The C1 is equals to 2. Okay. Okay. And then I mean, like, how do we get this thing? The C1 is equals to 2.
Here, okay. When you combine these, you get what? You got that is equal to C1 plus 0. Last pula dah. C1, 0, C1 plus 0, C2, 0 plus 0, C3, C3.
Yes.
Right.
Yes.
So when you combine this, you got C1 plus 0 plus 0. You got C1. Okay. Second, 0 plus C2 plus C3. So you have C2 plus C3.
Okay.
You get C1 plus 0 plus C3. So you get C1 plus C3.
Oh.
One row, right?
Yes.
Row 1 by 3. Right. So C1 equal to 2. C2 plus C3 equal to 1. C1 plus C3 equal to 0.
Okay, Doctor. Then we just substitute. Okay, we substitute. So we get C1 is equals to 2. C2 is equals to 3. Okay, Doctor.
Yep.
I understand.
Okay.
Okay.
Other question from other students?
Nope. I think we're good.
All right, good. So let's go ahead. So if you we can see from the example that generally some of the vectors in B can be written as a linear combination of the other vectors in B. Okay, but some may not. So one that can be written as linear combination of some other vectors in V are very special. So those who can be said to be contained in the span of the set that contains all the V's. Okay, let's see the definition of span X. V is in V and the set of linear combination of V1, V2, V3 and Vn is as a space of V and this is called a space spanned by S. Okay, this is called the space spanned by S. And it's written as span S equal to span V1, V2, V3 until Vn. And what does this mean? The set of span S contain all the linear combination of C1, V1 plus C2, V2 plus C3, V3 and so on, where all the Ci's are in R. So that's why we learned about the linear combination just now, because we want to find the set of span S. Okay, let's see examples to make it clear. Show that the span 1, 0, 0, 1, the set that contain 1, 0, 0, 1, the span of that set is equal to R2. Okay, so what we do? We find the C's. So it means that 1, 0, 0, 1 is a linear combination of C1, 1, 0. Okay, this is, if we call this S, this is span S. And equal to span of that 1, 0, 0, 1. So is equal to C1 plus 1, 0 plus C2, 1, 0. Okay, yang tak tulis pun tak apalah. So, kembangkan kita dapat apa? C1 plus 0, set coordinate 0 plus C2. So, the span of this set is in form of C1, C2, where C1, C2 in R. So, tapi apa ni sebenarnya? Ini kita boleh tulis sebagai XY, XY in R. If we look like this is what? XY, all XY in R. This is R squared. Any real number of XY. Can you see that? So we say that span of this set equal to R squared. Okay, what does this mean? It means that any vector in R squared can be written as linear combination of a vectors as 1, 0, 0, 1. Kiralah apa vector in R squared can be written as linear combination of vectors 1, 0, 0, 1. For example, take anyone. 2, negative 1. 2, negative 1 can be written as what? C1, 0, 1 plus C2, 0, 1. 1, 0, 0, 1 here. So we have what? C1 equal to 2, C2, 0, C2 equal to negative 1. So negative 1, 2, negative 1 can be written as 2, 1, 0 plus or negative 1, 0, 1. Negative 1, 0, 1. Okay. Any vector you take from R2, it can be written as linear combination of 1, 0, 0, 1. Any. This is the example I give. How about negative 3, 2? Can be written as what? Anybody? can be written as linear combination C1 as 1001. What are the C's? Hello, are you guys here?
Yes, Doctor, I'm here.
Apa? Negatif 3, 10 plus 2, 0, 1.
So
Betul tak?
our C1 will become negative 3 and C2 is 2.
Yep. Terus
Yeah.
je kan? Ini what we call like base identity. 1001.
Yes.
Okay. Similarly, okay, and do the example. In other words. Okay, similarly for 3 by 3. So we have 100, 010, 001. It is R3. Why I said R3? Same thing.
3C.
Yup. We have C1, C2, C3s. And it can be written as XYZ, XYZ R. So this is none other than R cube.
Okay.
Okay, so any vector in R cube can be written as linear combination of vectors 100, 010, and 001. Example, ambil apa-apa lah. 4, 2, negative 1. It can be written as 4, 1, 0, 0 plus 2, 0, 1, 0 plus...
Doctor, where do we get the 4, 2, negative 1?
No, any vector. I just pick.
Okay.
Okay, negative 1, 0, 0, 1. Let's see what? Any vector can be written as R3 can be written as linear combination of 1, 0, 0,
Okay.
0, 1, 0, and 0, 0, 1.
Okay.
Okay? Okay, find this one. Find span of 1, 0. How many C's here? This question number 3, how many C?
It's only 1 C.
One C.
Right.
So if it is 1 C means so C1 is equals to 1. 1 lah kan?
That's right.
Yeah.
C1, 1, 0. So we have what? C1, 0, right? So
Yes.
the spanning set of 1, 0 in the form of C1, 0. So we have
Okay.
C1 R. So C1, 0. So that means it is X0. So all the X coordinate that multiply by 1, 0, right?
Yes.
So the vector, the spanning set of 1, 0, how does it look like? It looks like all the x-axis. A vector along the x-axis. One zero, 20, 30, 40, negative 10, and so on along all the x-axis. Okay? Can we go on?
Yes, can doctor.
Yes, doctor.
Okay, number 4. Find the span of. Oh, you already have it here. Show the span of that matrices M2 by 2. Okay, dapat tak? How many C's? 4 C's, right? Set of span of that is equal to the set C1 times 1001 plus C2 0100 plus C3 0010 plus C4 0001. Macam tadi kan? So if you combine all those, you get C1 plus 0 C2 plus 0 C3 plus 0 C4. So you got C1. 0 C1 plus 1 C2 plus 0 C3 plus 0 C4, you got C2. And so on, C3 and C4. Sis,
2 by 2 matrix.
yeah, that's it. 2 by 2 matrices. That's right. Long, right? Okay. Let's go on. Any question? Okay, let's go to the theorem.
No, doctor. So far, so good.
Okay. let S be the set that contain all the vectors. Okay, it's just a vector space V. Then the set that we did, all the examples just now, the set of span S is actually a subspace of V. Remember how to prove a subspace? Remember? The subspace must be the shortcut ways. 3 things that you need to prove a
It
subspace.
must be included, right, Doctor?
The first one must be non-empty.
Yes.
Right? Usually we take the identity, right? The second one must be closed under addition. And the third one must be closed under scalar multiplication, right?
Yes, Doctor.
Okay. So now we need to prove this. Span of S is a subspace of V. Okay, remember what is span of S just now? It's a linear combination of those. C1 V1 plus C2 V2 plus C3 V3 and so on. Now, number 1 is identity. Is this span S non-empty? Is this span of S non-empty? For sure, right? Because 0 is in it. 0 is in span of S because 0 can be written as 0 times V1 plus 0 times V2 and so on. Okay, remember when you want to show non-empty, go back to the identity. Usually. Okay, number 2, close under addition. We take 2 elements in span of S. Let's take X and Y in span of S. We want to show, what do you want to show? Is X plus Y is in span of S.
Yes or not?
Okay, how does X look like? X linear combination because X in span of S is linear. X is a linear combination of all the V's. Let's put it. X is C1 V1 plus C2 V2 plus Cn Vn. Right. Same thing with Y. Y
Y
is a
is
linear.
also D. Yeah.
Okay? Because
But
it's
then,
every
Doctor.
element. Yeah.
Okay, sorry, Doctor. Yang we replace X. I mean, like X is equals to C1 V1 plus C2 V2 and so on. Then
Okay.
Y is equals to D V1 D1 V1 plus D2
Okay.
V2.
Let me see the what do you call it? The coefficient are not the same.
Oh, okay.
X, for example, just now we look. For example, for the X, maybe C1 equal to 2, C2 equal to 3. For
Okay.
Y, maybe C1 equal to 4, C2 equal to 5. Maybe.
Uh-huh.
So we cannot put the same C's.
Oh, okay.
Right?
Yes.
X is a linear combination of those B's. Y is a linear combination of those B's. X and Y is in span of S.
So it's both under a span of S, right?
Yes, that's
Yes.
right.
Okay.
Both under
Okay.
element of span of S. So now we want to find is X plus Y in span of S. So we just combine it. Add that together. What do we have? We have that. And equate the coefficient. Not equate the coefficient. Combine the same coefficient. We have that. Then put it in this way so that you can see the coefficient of V1, the coefficient of V2, the coefficient of Vn.
Okay.
Okay. C1 is in R, so we want to know. The question is X plus Y in span of S? In other words, we want to find, let's put K lah. You want to find the case such that X plus Y can be written as KV1 plus KV2 plus blah 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 plus KVN, where K is in R. That's what we want to find.
Okay.
K. Kan?
Yeah.
But what is C1 plus D1? C1 is real. D1 is real. So C1 plus D1 also reals. So I can put K1, C1 plus D1 equal to K1. K1, sorry. K1. K1, K2, Kn. C2 is real. D2 is real. I can put C2 plus D2 as K2. And so on. Right.
Yes.
So now shows that X plus Y is in span of
Span
S.
of S. Okay. So which means also we just take the C1 plus D1 replace with the K. If in case
Yeah.
we want to replace
Just
with K. Okay, okay. Faham, Doctor.
okay. Next proof. Want to show it closed under linear. It's closed under scalar multiplication. So we take only one element in span of S. Let's say X. We want to see is Kx in span of S. Okay. So X in form of C1V1 plus C2V2 plus Cnvn. So we want to see is Kx can be written as, let's put anything here. Y lah. No, D lah. Want to put D. D1 V1 plus D2 V2 plus DVN. D must be reals. Is that true? Barulah, if it's true, then we say that of S is closed under scalar multiplication. So, what is Kx then? Kx is K times Z, right? And then, can times K inside.
So in this case, yeah. Okay, Doctor. Continue. Okay.
Okay, this is all real, so that means we can just omit the bracket, right?
Yes.
Omit the bracket. So now, our KC1 is D, our KC2 is at D1, our KC2 is D2, and so on.
Yeah. So C1, C2, and Cn will be D. This is
So
D.
in my notes, I put
Yes.
L. In my notes, I put L. So saya buat sini L lah, L1, L2. L1, L2, sini Ln. Okay? Alright? Any question?
No, Doctor. So far, okay.
Alright, so the example. So here we already proved 3 things. So we conclude that span of S is a subspace of P. Okay? Examples. Let S be that set of R3, want to show that 111 is not in span of S. 111 is not span of S. If 111 is span of S, then 111 can be written as linear combination of 4, 2, negative 3, 2, 1, negative 2, negative 2, 1, 0. Okay. So let's see whether we can find the T's.
But doctor, if they said it is not under the span of S means which means they ask us to prove that, right?
Yeah, the question asks you to prove that. That means we cannot find the C's.
Okay.
Right.
Yes.
So let's say this. Can we find the C's then?
I don't think so.
So that means you should not get the C's because it asks you to show that it is not span.
Yes.
It's not in the span of S. So let's
And
try. So kita dapat apa? You get that? Again, no shortcut. No back substitution here. Need to use the Gordon elimination. What is it? Siapa ni? Kat mana dah kita? Where are we? Page number 10.
up some more, doctor.
Up. Page number 10. Here.
Yeah.
Okay.
Bawah lagi. Yeah.
Right, there's one, right?
Yes.
Okay. Means we need to use the Gordon elimination lah. Buatlah macam biasa. Tengok ada tak C. Bla 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 bla. We got 0, 0, 0 equal to 1. So what does
No
this mean?
solution.
No
No
solution. Yes, we have proved that. So that means no CI such that this is true, and we prove that 111 is not in the span.
The span of S.
Okay?
Okay.
Need to copy because you have the videos, right?
Yes.
Okay, let's try to see one more example, then we stop. We have 15 more minutes. One more example. Let S equal to 1, 2 in R2. Show that span of S equal to that one. X, Y equal to 2X. Je kan? Macam biasa lah tadi kan? Span of S, linear combination of 1, 2. So we have 1C. So span of S should look like C, 1, 2.
Yes.
Okay. Multiply it, we have C, 2C.
Yes.
So if we put X as C, we have X. In other words, all coordinate of Y in the form of 2 times coordinate of X.
Doctor, wait. In this thing, they said Y is equals to 2X, is it? So
Yeah.
at the place of Y, we represent as 2X. So
Yep.
Then why the
So
C
here,
become X?
okay. Because I want to put in form of, tak payah tukar pun tak apa, but I want to put in form of R2.
Oh,
R2
okay.
dalam XY dan koordinatnya XY.
Uh-huh.
So if I put C equal to X,
Uh-huh.
here 2C is equal to 2X kan?
Yes.
So here coordinate X, here coordinate Y.
Why? Okay.
Right.
Yes, yes, yes.
So the set of span S in the form of XY where the coordinate Y equal to 2 times coordinate of X.
Okay.
Right.
Yes.
Okay. Give 2 vectors in span of S. Give 2 vectors. Anyone?
2, 3 maybe?
2, 3 is 2, 3 in span of S.
No.
Kalau 2, 3, kalau you bagi 2, 3,
Mm-hmm.
adakah ini X kan?
Yes.
Ini Y.
No,
Adakah Y
no.
sama dengan 2 X?
No, doctor.
So instead of 2, 3, you should give what?
4.
2, 4.
4, that's right. So 2, 4 in span of S.
Yes.
Apa lagi?
6.
3, 6?
3, 6. 2, 6 cannot. 3, 6. Ada
Yes.
lagi?
5, 10.
5, 10. So all where Y is 2X. Okay, just give anything. I give 2, 4 and negative 2, negative 4.
So maksudnya doctor, for the thing
Ah.
like they said Y is equals to 2X like gandaan 2, right?
Ya, betul.
Okay.
Give 2 vectors is not in the span of S. Dah
Two,
dapat
three
satu
then.
dah. Itu dia bagi.
2, 3 then.
Okay. 2, 3, 2, 0. So, what we learn about linear combination, because we want to go to the definition, or we want to go to the terms that call spanning set, span of S. Because span S, the set of span of S is the linear combination of all the vectors in V. Okay, that's why we learn about linear just now, linear combination. We want to go here. So any question before we stop?
No, doctor.
Oh, doctor.